All right, so I wrapped that up. I just listened to it and I sound stupid, but I don't even care. It's 10:17. We're just rocking. All right, so once again, these two examples are very similar. We have something small minding its own business. A large amount of energy comes in. It excites it. That's what it's called when we bounce the electron to a higher level. All right, it's excited. It jumps up, but everything in nature has to come back down, and as it comes down, it gives off energy. For the electron, it's in the form of light. For the cheerleader, it's in the form of a scream and the motion of running down or whatever, all right? All that comes back down. If you took physics, you'll remember as you fall down, you're changing your potential into your kinetic, and eventually she'll land on the trampoline, just like the electron will come back down to the metal, and we see that spark. So this is the photoelectric effect that Einstein saw. He wanted to know why these light photons that came out in different colors. So he thought of Planck's idea. He says, hey, energy is quantized. So maybe if it only jumps up a little bit, it only falls a little bit. This is exactly the same as the stairs. If it jumps a lot, it falls a lot. And the distance that they fall, so to say, are proportional to the color of light that they give off. Okay, all right, here we go. He called these particles photons. Until that time, light was thought to be only energy carried in the form of waves. All right, now, if you remember from physics, this will be really hard to draw. We said that light had this wave structure. Okay, so it had like an up and down, and then it had like an in and out of the board type of thing. I don't know if you remember that, or even if you had physics, but you'd have these arrows pointing down and these pointing up, and so forth and so on, and that's terrible. But, all right, so we knew that light had wave properties, but now Einstein's saying that they have particle properties. All right, this is a huge shift in theory. Like, unbelievable. Now, we know light travels as a wave. We know it. It has to. It has properties of waves. It will reflect. It will refract, more importantly. But we also now know that it behaves as a particle as well. So this is called the dual nature of light, that it possesses the properties of both a particle and the properties of a wave. Now, I'm going to guess that most of you by now have put a darker mustache on Einstein. Probably, highlighted this. And maybe you've given him an earring. I don't know. I get these turned in, and it's always fun to see what you've done to his face. Should we give him a little, what do you call that, a soul patch? Oops. All right. Flavor saver. All right, whatever. All sorts of things. I'm sure you've done it, so I might as well do it too. Let's give him a little bit of red eye. Looks pretty good. Kind of looks like that one vampire, the redhead that gets torn into a million pieces. Melanie? Not Victoria, the boy. Victoria's boyfriend that she's all mad at. And if you don't know what I'm talking about, you should be ashamed. Okay, so whatever. Take my man card. I don't care. So here's Einstein. I'm just killing time. We got more notes to do. All right, let's move on.